So welcome back, Level 3 NCEA Physicists. Today, again, continuing with the electrical systems external and looking at the measuring of circuits. Okay, so in order to look at the measuring of circuits, we've got to consider something called the observer effect. So essentially, the observer effect says that whenever you're taking any kind of scientific measurement, there's always a possibility that the very act of measurement will change the value that is being measured. Okay, and we do see this with electrical systems because when we're measuring the voltage or current in a circuit through a voltmeter, ammeter, or multimeter, what we want to do is we want to minimize the effect of our tool on the circuit so we can get the most accurate results, because actually introducing these components to the circuit do actually affect the result, and that's what we're going to look at today. So in terms of an ammeter, okay, an ammeter is hooked up in series to the component being measured, and ideally we want the resistance, therefore, of an ammeter to be 0 ohms. Okay, and to illustrate this point, what is the reading for the current flowing through an ammeter if it added to a circuit when the ammeter's resistance is 1 ohm? Well, that means the total resistance now changes from being 10 ohms to 11 ohms. So the current, being voltage over resistance, or total voltage over total resistance, will be 10 divided by 11, or 0.9 amps now, whereas the actual measurement should be closer to 1 amp. So just adding the ammeter changes the value. And it's the same with a voltmeter. So voltmeters should be hooked up in parallel with the component being measured, and this time the resistance should be basically infinite ohms, because we don't want it to go through the voltmeter, we want to go through the component, measuring the potential difference. Okay, and again, it's illustrated here. What if the voltmeter is not ideal? Okay, so here we have an example. What will the reading for the voltmeter be across R1 if this added resistance is 20 ohms? Okay, so what you'll actually see is now the voltage across the resistance will be 4.5 volts. The resistance, instead of now reading 5 for R1, will also be 4.5 volts. And the resistance for 2 will be elevated. It will be 5.5 volts. And the current will be 1.1 amps, because the total voltage will still remain 10. But now the total resistance is now 9 ohms instead of what it should be, due to the extra addition of the internal resistance of the voltmeter. Looking at power. Okay, so the symbol for power is, of course, capital P. The units are watts, which is capital W, and we've got some new equations now from level 2. So power equals voltage times current, and if you substitute Ohm's law, V equals IR, into these equations, then you also get two new equations, P equals I squared times R, and P equals V squared divided by R. And different devices, different power. So essentially it requires a lot more energy per second to, say, heat water or heat air. So therefore something like a hairdryer requires a lot more power, a lot more joules are converted per second to dry your hair than, say, for a DVD player. Okay, so there's different devices with different jobs in the house require different power values. And finally, looking at resistance, what affects the resistance of the wire? Well, there's a number of components that you must consider. So you've got the area of the wire, you're looking at the cross-sectional area, you've got the length of the wire, the material the wire is made of, and also, more importantly, I guess, in terms of filament lamps and why they're non-ohmic rather than ohmic conductors, is because as the temperature of an object increases, so does the resistance. The reason why, of course, is that as something heats up, the particles inside the conductor begin to vibrate more, which means there is now more chance of collisions of the electrons with those particles in the conductor. Sig, for example, a metal, those positive nuclei. So therefore, that means the resistance of the wire increases with increasing temperature. Okay.